What is up, guys? Fa here from AwesomeTunes.com, and back at it again with another Unreal Engine C++ tutorial. This time we have a really cool game that I call Run to Survive, where we have enemies, pickable items, timers, and all of that stuff. So I'm going to zip it and let me show you the game that we have here. So basically we have 3 enemies currently that you can see that you can easily turn into 40, 50, 50, 60, 100 gazillion. You get the point. You can simply duplicate enemies, and I'm also going to show you how you can add more multiple enemies, different enemies, animate them, and all of that stuff. And the enemies are going to go and roam in this space over here. So in this field, they're going to roam, and I need to move them just a little bit away from the player because this is their sphere that can detect players' presence. And when they detect that player presence, because the player is going to spawn over here, they're going to start running towards the player. So if I hit the play button, look at the enemies. They are going to search. So currently they're searching and roaming in the space over here. And if I eject myself, you're going to see that the enemies are searching, but this one is going to, okay, he did not find the player. They're searching on random. So they're roaming here on random. And when they detect where the player is, they are going to get close to the player and they're going to start attacking the player. Now the Parasite, I set his damage to be the highest. So it basically needs to touch us 2 times to kill us. But over here, if I pick up these items that I cannot do right now, so I'm going to let him to kill me. So look at that. 1 attack, 2nd attack, game over, and now the game is going to be restarted, and there you go. If I pick up all of these, 1, 2, 3, 4, there you go, game over, you win, and voila. And notice here, we are also displaying that in our UI. So items remaining currently 3, then 2, then 1, and also look at the health at the top left corner. When the enemy attacks us, look at that. So he's dealing damage, and that damage, you know, so the damage is being dealt and it's being displayed. And when I run away from the enemy, he's going to continue to search for me and attack me. And the goal is, of course, to avoid the enemies, not get killed by the timer, and pick up all collectible items. And of course, you can see over here that you can add multiple enemies that I'm going to show you. We got these enemies from Mixamo. I have a tutorial for that as well. So we're going to get them, animate the movement, the attack, all of this stuff, the damage, and basically everything is done in C++. Of course, you cannot avoid blueprints. Some things are done in blueprints, but 2% of this whole game is done in blueprints, such as the UI, displaying the UI, that is done in blueprints. Everything else, the AI, the enemies, the movement, the player movement, all of that is done in pure C++. So, as you can see, a really, really cool game. So I'm going to, you know, zip it, and yeah, I don't have everything else clever to say, except if you want to access all of these videos, if you're watching this on YouTube and not in my Game Development Academy, you can access all of these videos right away in my Game Development Academy. You will not have to wait today and then tomorrow for me to publish the next video and then the next video. It has 16 or 20 videos, around 15, 16 videos, I believe. So that is 16 days that you will have to wait for every single video to come out. But hey, you can also wait. And hey, if you don't want to wait, you can join in the game development. Again, you can join. Anyways, let me just shut up and let's watch the video. Alrighty then, my game dev gangsteronios. Here we are in our project browser window. So we are going to create a new project, and over here we're going to click on games because, you know, we're not a producer to create film and television. We're not an architect and all of that stuff, and you definitely don't create cars. So we're going to click here on games and click on next. Now we are not going to take the blank project. Instead, we're going to take the 3rd person one because, well, we want the 3rd person one. And we're going to click here next, and over here is where the magic is going to happen, because I know all of you guys, you love it when I say we're going to change this from blueprint to C++. Oh no, how does that feel? How does that feel? Just kidding. Anyways, everything else is going to stay the same. So the quality with starter content, make sure that you have the starter content. And of course, choose your destination where you want to store the project. Click on create. I have already created the project because, how I said this, I don't go to your project. Anyways, I have already created the project because, you know, it takes a lot of time. But even though, since the last tutorial, I got my new hard drive, SSD, and it's a lot faster. Thank you for asking. So what we are going to do in this video is we are going to prepare the level. Of course, you see this default level that we have and all of that stuff. We are not going to, you know, use all of that. So we are going to prepare our level. And we are going to also prepare the input for our game. So what I'm going to do is I'm going to take this area, I'm going to remove all of these. Should I remove these walls? Yes, I'm going to remove these walls because I'm going to create my own ones, okay? So over here, I'm going to select them and delete them. Come on, there you go. Thank you for deleting these. And what is this over here? So we have this floor. Yeah, I'm also going to delete this floor because I'm a bad boy, but I'm going to leave this right here, the walkway. This is how it is called apparently. And this arena geometry, I'm going to change the name to level because, you know, this is going to be my level. Over here, I am going to change this arena to ground, and for the ground I am going to go here inside of the content and filter for template floor, and there you go. So this is the one that we want. I am going to simply put him here in the ground folder and call him ground. There we go. Now for the X position of the ground, we are going to set that to 0. Y position is also going to be 0, and the Z position is going to be 130. There you go, something like this. Now, when it comes to the scale over here, I am going to set the X scale to 1.5. The Y scale is going to be 1.5, and the Z scale is going to be 0.15. So this is going to basically be our level. Now over here, I don't think that we need any of these. No, we don't. So this light mask, this processing volume, we don't need that as well. So you can delete all of that. But what we do need are the walls. So for the walls, I am going to right click here in the level and create a new subfolder, and I'm going to call it walls. And for our walls, we are going to filter here inside of this project browser. So we are going to filter for floor. Let me just find it here, floor, and we want this floor 400 by 400. There you go. So this is the one that we want. And I'm going to drag it here in the walls and, you know, rename him to wall 1. Simple as that. What did you expect? Now for the X position for this one, I'm going to say minus 3000. For the Y position is going to be minus, so not plus, let me find here, minus 3020, and the Z is going to be 100. This is where I'm going to position this bad boy, and I'm also going to rotate him. So over here, I'm going to say minus 90 degrees, and the X scale is going to be 15. And that's that. I'm not going to touch the Y scale and all of that other stuff. I am going to hold control and drag this, you know, over here. So it's going to create a duplicate. And for this one, I'm going to position him at 3000 on the Y axis, which is simply going to position him over here and form a wall. That's all there is to it. Now going from here, selecting wall 2, I'm again going to hold control, actually alt, excuse me, and from here move simply to create a duplicate. And this one, I'm going to position him at minus 3020, so 3020. The Y position is also going to be 3020, but this one is going to be the positive. And the rotation over here is going to be X minus 90 degrees, and Z is also going to be minus 90 degrees, which is going to make him rotate like this, and it is going to form. Now, of course, what we can do is over here, I am going to change the scale for this one from 15 to 15.1 like that, and there you go. So it's going to fill out this gap that we had, that you just, well, saw. Again, holding Alt and duplicating this one. This is going to be our wall 4, and this one is going to be on 3000 on the X. Y is going to stay the same. Everything else is going to stay the same, and this is our level. There you go. Of course, we can run the game and play it with the default character that we have that is created because, you know, we selected the template for the third-person character. But again, we're going to do everything from scratch with C++, so we are good programmers, and this is what we do. Now, before I move, we are also going to set up our input. But also one thing that I want to point out is this right here, because I found that annoying. And it's basically the small letters and everything in Unreal Engine that you can fix basically by going here in Windows, Developer Tools, and over here going into the widget reflector. So over here, application scale, by default, it is set to 1. And as soon as I set it to 1, you will see that the letters over here, for example, this location, it's, you know, a lot smaller and all of that stuff. So there you go. If you want to fix that, I set mine to 1.25. 16, and it looks a lot better and also more clear for you to watch, this tutorial. Now over here, also into the third person CPP and maps, I'm going to change this third person map to simply gameplay, like that. This is the name of my map, and then I am going to go here into the project settings and then input, and from here we are going to change our input. Now we don't need this reset VR at all, so I'm going to simply delete it. For the jump over here, we basically only need space, so we can delete everything else except the space bar. Over here for our axes, we need to move forward, move right, look up, and we also need the turn. So we don't want the look up rate, we can delete that. The turn rate, we can also delete that. Here for the move forward, I can simply delete everything except the WS up and down. This is what I'm going to use. For the move right, do the same thing. Just over here, I'm going to delete everything and leave AD. And you can add, for example, left. So let me just find it here. There you go, left, which is, going to be -1 because it's going to the left side. And over here, you can find right, which is the right arrow key, which can be 1 because we are going to the, right side. And over here, you have the mouse X, and over here, you have the mouse Y. That would be it. This is the initial setup for our game. Of course, starting from the next video, we're going to start to code our character, and then we're going to see how that works. So yeah, if you have any questions for what we did so far, or any questions about life, about nature, about, pictures, books, just ask them down below and I will not answer them. Just kidding. Anyways, this is it for this video. And yes, if you do have questions, ask them down below, and I will see you guys in the next video. Alrighty then, my game dev gangsteronio. We are here in the C++ classes and our run to survive game. Of course, we don't need this third person character, so we can safely delete him from here. We don't, go away. We don't need you. And over here, we're going to right click and create a new C++ class, and it's going to inherit from the character. I'm going to click here next, and I am going to change the name from my character to simply player character. So player, there we go. Player character, and I am going to click here, simply create class, which is going to create it. And of course, now I have my SSD, which is M2, by the way. Thank you for asking for your, and it's a lot faster, as you can see. Of course, still Unreal Engine takes a little bit of time to do its thing, but it runs fast. I have, 2 instances of Unreal Engine opened. I have other programs and all of that stuff. Why am I telling you this? Why am I telling you this? Instead, I should be singing, "Where's my ukulele?" I'm just kidding. This is not the ukulele. This is starting to get awkward. Even my SSD cannot handle this. Anyways, I'm just kidding. Having fun when I'm creating these tutorials. Why am I saying every single time? I'm just kidding, because you already know that. I feel like this is a podcast, but I'm talking to myself, and there you go. Finally. Finally, it now is completed, and there you go. So I'm going to reload this because, we created a new class or a new C++ class. There you go. So this is our player.h file, and come on, Microsoft Studio, Visual, whatever. Now okay, there you go. We're good. So going over here, I'm also going to open the player CPP because this is where we're going to implement everything. And in the player.age is where we are going to declare everything. Now, before we start to do anything, if you are a complete beginner and want to follow this, I would recommend that you pass by my Unreal Engine, or actually C++ tutorials for Unreal Engine. They're titled like Learning C++ for Unreal. Make sure that you go through these because, some things I'm not going to explain in that depth. So anyways, over here, we're going to create a U property, and it's going to be visible. So visible like that anywhere. And this is going to be blueprint read only because we're going to only allow the blueprint to read it. And I am going to put this into the category of the camera. So over here, I'm going to say category equal to camera. There you go. Now, visible anywhere will, when we click on it, the properties will be visible for this component. Blueprint read only means that the blueprint can only read it. It cannot edit the values. And category is basically when you right click in the blueprint and you search for this particular component, it will be under the camera category inside. Now, we want the use spring, not sprint, but spring arm component. And it's going to be a pointer, so we need to add the star, and this is going to be our camera boom. Now, automatically, you're going to see that Visual Studio is complaining. That is because we don't have this, we didn't include it over here. So instead of including this in the .h file, we're going to include it in the .cpp file. So over here in the .h file, I'm simply going to add class in front of it, and this is called forward declaration. Now, the reason for that is because same as with Unity or any other software programming whatnot, we have libraries which are predefined code snippets, or however you want to call them, basically the predefined code that we can use in our programming. Now, in order to use that predefined code, we need to import it by using include, so that, this file knows the path to that predefined code and it can use it from that path. Otherwise, if we don't include it, it will not know where it is. Now, if you include it in the .h file, then it's going to be complicated, because every single time you include this .h file, it will include all the h files that you have included inside. And that can be troublesome, tedious, it can, run slow, and so on and so forth. So instead of doing all of that, you're simply going to forward declare the class over here, and then later on in the .cpp file, use the import. Now, I am going to copy this and I am going to paste it. And this one is going to be camera component, because we need the boom, which is going to be the spring arm that is going to hold the camera, and we need the camera. So over here, I'm going to call this one follow camera. There we go. We are now going to, this was under public, as you can see over here. So now we are going to create the protected. And if you don't know what is public, what is protected, I highly, highly, highly recommend that you go through the C++ tutorial series, or otherwise you will have these issues. Now over here, I'm going to create void move forward function that we are going to use to move forward. So it's move forward like that, which is going to take a float value as a parameter, and also void move right, which again, taking a float value as a parameter. Over here, we're going to have void mouse underscore x, and this is going to control the mouse movement on the x-axis, which again is going to take a float value. There you go. And void mouse underscore y, which, float value, you get the point. This one is going to control the mouse movement on the y-axis. Now, this can be mouse y without the underscore like that, but sometimes I like to put underscore, even though that's not, the industry standard. And now I'm going to be bombarded. Oh, you are not coding with the industry standards. Listen. Sometimes, I do that just so that I can differentiate. So for example, this one is mouse. It starts with the mouse. So when I add the underscore here and add the underscore here, it's a lot easier to read. At least this is what I do in my own development. Maybe if I work for a company, they tell me, don't do that, and I will not do it. Simple. Next, I'm going to create over here f rotator, and I'm going to say this camera rotation, which is going to be equal to f rotator. And this is just for the initialization, because we're going to use this to rotate our player. And last but not least, we're going to have a f vector move direction, and that's going to be equal to f vector, like that. There you go. Now, you will notice below these functions, move forward, move right, and all of that stuff, you will notice these green lines basically telling us, hey, you declared these, but you did not implement them over here inside of the .cpp file. So you're crazy, and we need to not be crazy, so I'm going to implement it. Now, how we can implement this, we can go over here, and we can, create something like this. We can say void a player character, like that, colon, then use the name of the function, move forward, and like that. But you see, this can be a lot, work. It can be tedious, it can be whatnot. So we are simply going to go here, click on this function name, move forward, right click on it, quick actions and refactoring, and here create declare definition. There you go. It's done for us because we're lazy. So I'm going to right click again on the move right and go here, create declaration. There you go. Do the same thing with the mouse X and the mouse Y. So create the declaration, definition, whatever. Over here, quick actions refactoring, create declaration, definition. Voila, there you go. I am a bad boy. And you get the point. So what we are going to do in the .cpp file. First things first, we are going to have the includes for what I was talking about a moment ago when it comes to these, components and everything that we want to use in our code that we need to import or include in this case. So over here, I am simply going to include, and we're going to have components. So components and then slash, and this is going to be static mesh component and .age. And this is how we include these components. I'm going to include all the components that we need for this particular class. So I'm simply going to paste them here, and you can pause the video right now because as you can see, it's a little bit tedious. You can, watch me typing, okay, include this, include that, and all of that stuff. This right here, the last one, which is throwing an error, I am going to position it here and I'm going to comment it out. We will need this later on, and this is going to be our game mode, but we are still going to create our game mode. Don't worry about that. We will create in this video or in the next one. And when we do, we are going to include the game mode because later on our game mode is going to have some variables and some information that we need to access, and we will see all of that. Now we need the static mesh component, we need the camera component, we need the spring arm, we need the character movement, the world from the engine, the Kismet, gameplay statics, check the statistics, and all of that stuff. So what we are going to do inside of the constructor over here, so you can see this is our A player character, the constructor, and this is where we are going to construct all of these components. So first things first, our camera boom. So there we go, is going to be equal to, and first we need to create it. So we're going to say create default sub object type of U spring arm component, and I am going to give it a name over here. So we're going to pass a text file, or actually a text parameter, not a file, and I'm going to call this one camera spring arm. There we go. Now below we are going to make the camera or set it up on the root component. So we're going to say camera boom, and from here I am going to say set up attachment, and we are going to attach it on the root component, which is basically going to make it a child of the root component. Next I'm going to say camera boom. So camera boom, and from here we're going to say set relative location, and I'm going to set that to f vector. And it's going to be 0.0 for the X, 0.0 for the Y, 0.0 for the Z. Relative location is the location relative to the parent. So it's not relative to the world, it's relative to the parent. And over here, I'm going to say camera boom dash greater than sign, and I'm going to say set relative rotation, and it's going to take a F rotator. And over here, 0.0 F. For the, so point, not comma. For the Y, I'm going to say minus 20.0 F, and for the Z axis is going to be 350.0 F on the Z axis. I already said that. I'm also going to say here camera boom, and from here I'm going to say target arm length. I'm going to set that 550.0. The target arm length is basically how far away is the camera boom from the player. So for example, if the player is here and this is our player, the camera boom is going to be attached on the player. And if we say the target arm length is 550, it's going to be, for example, somewhere around here, that camera boom. And then when we attach the camera on it, the camera is also going to be here, and the camera will be looking at the player. You can imagine this is some kind of camera because I am a good drawer. There you go. So this is a camera looking at the player. Now that we created the camera boom, we do need to create the camera. So here I'm going to say follow camera is going to be equal to create default sub object, and is going to be U camera component. So camera component, there you go. And from here I'm going to pass a text and give it a name, and this is the name that's going to be previewed, or this is the name of the component when we create a blueprint from it, and I'm going to call it follow camera. Not camera, it's camera. There you go. And next we are going to have follow camera, and we are going to set it up. So from here, I am going to set up attachment, and I'm going to set it on the camera boom. So we're going to attach it on the target arm component or spring arm, and we're going to say spring arm component socket name, which is basically going to simply position it, make it a child of the camera boom. Now I can compile this, so Control-Shift-B, and this is going to be compiled, and we need to wait a moment or two. There you go, succeeded. And now what I can do is go inside over here, and in the content I'm going to right click and create a new folder, and I'm going to call this one blueprints. And from here I'm going to right click, create a blueprint class, and filter here for all classes. I'm going to filter for player character. There you go, and click select, and I'm going to call it BP player character. You get the point. It's player. I cannot, I forgot when I said that the last time. Okay. So what we are going to do right now is open the blueprint, and we are going to create our player. As you can see, this is the camera boom. There you go. Look at that. This is the camera boom. And you see the red line representing how far away is it from the player. So this is the arm length. And this is the camera that is attached on it. So very, very simple. Now what I'm going to do is I'm going to take my static mesh, and I am going to filter here for the skeletal mesh, and I'm going to take the mannequin, which is this one. And I'm also going to position him, so on the z-axis minus 90 degrees, on the z rotation I'm going to say minus 90 degrees, so that he is, rotating. Well, he is rotated like this. There you go. And next, I'm also here for the animation blueprint. I'm going to click and search for the third person anim BP, which is the animation of the character. Make sure that you simply compile and save that. And now for our camera boom, over here for the rotation, I'm going to change this to 0 for the X. For the Y, it's going to be 350, and for the Z, it can stay at minus 19 point whatever this number is. And over here, the Z position, I'm going to set that to 60, and it's going to position, as you can see, the player and the camera like that. And that's pretty much it when it comes to our player. So we can compile and save that. Now, I cannot run the game. I mean, I can run the game, but we will not have our own player. This is the previous one, third person character. He is not our own. As you can see, we can move and everything. This is something that we did not code for our player. But in order for us to actually be able to create our own player or run the game with our own player, we need to go back here in the C++ and right click over here, create a new class, which is going to inherit. So click here, show all classes. So over here, and from the search list, I'm going to filter for game mode, and we want this game mode over here. So we want to inherit from the game mode. Click on next, and I am going to call this one run to survive. There you go, _ game mode. This is going to be our game mode. I'm going to click here to create, and it's going to add that to the project and all of that stuff. I'm thinking, should I cut out the video? But look at that. Now, this is the power of the SSD. Look at that. Well, I'll still, there we go. Okay, it's compiled. Thank you. So anyways, we do need to reload this. There you go, reload. We're not going to do anything now with the game mode, but we do need it to create a blueprint from it. So inside the blueprints, right click and blueprint class. And from here, we're going to filter run to survive. So survive. And we want the game mode. There we go. This one, run to survive _ game mode. And I'm going to say BP _ run to survive _ game mode. Now, the reason why we need this is because inside of our project settings and over here for maps and modes, we need to select our own default, or actually our own game mode that we have just created. So click here, and we want the BP run to survive game mode, which now allows us over here to select a default pawn who is going to be spawned when the game runs, which is basically, if I click here, our BP player character. So he is the one. If I click the play button right now, this is our character. Now, of course, we cannot do anything. We cannot move him. We cannot rotate. We cannot do anything because we still did not create all of that. We just created our character. We attached everything, and that is that. This is basically the preparation for it. So this video is already getting too long, and I'm going to cut it out here. And in the next video, I am going to code the movement, code the rotation, and we are going to learn a lot of cool things. Of course, if you don't want to wait, you can access the full tutorial series, this one in my Game Development Academy. Link will be down in the description, so you can access this tutorial along with 80 other courses with Unreal Engine, Unity if you want to learn Unity, and you don't have to wait for me every single day to publish a video for you to learn. So that will be it. If something is not clear, make sure that you ask in the comment down below, and I will see you in the next video. So in the previous video, we just created the character and we have spawned him in our game, but now we need to make him move. And in order to make our character move, we do need to go here in the player.cpp. And the first thing we need to do is bind these functions inside of the setup player input component. Because if you remember, 2 videos ago, I think, 2 videos, we created here, it's right here in the input. I got confused there for a second. So it's right here. We created these axis mappings and this action mappings, or basically we just deleted the ones that we don't need. They were already created. So we need to map these in our code in order for them to work. Now, in order to do that, that happens over here inside of the setup player input component. As you can see, call to bind the functionality to input. So first things first, I'm going to say player input component, and I'm going to say bind axes, and I'm going to bind move forward. So move forward, which is the name. So this move forward is actually the name of the axis over here inside of the project settings. As you can see, look at that. So move forward, that is the name, and the name over here, this name right here, the capitalization and everything needs to match up with the name over here, otherwise it will not work. So I'm going to bind it inside of this, referring to this class, and I'm going to bind it to the function, and we need to add this and sign, and we need to bind it to this a player character move forward. So simply copy and paste this over here, and there you go. That's pretty much everything we need to do. Now I'm going to do the same thing for the move right. So I'm going to copy this and paste it, and over here instead of move forward, I am going to say move right, and here instead of move forward, it's going to be move right, and there you go. So we have bound or binded 2 functions to the functionality, which means when we press the buttons that are designated or that we set up over here, so when we press the W, S, up or down buttons, then this right here move forward will be called. Now we also need to bind 4 more, and over here I'm going to say player input component, and this time instead of binding the axis, we want to also, this time also binding the axis, and after that we will bind the action. So bind axis, and this is going to be turn, which is our move right inside of this, and again we need to get this over here. So move or mouse X. I'm going to copy this with the and there you go. Again, I will have to copy this and paste it over here. So this time this is going to be look up. There we go. This, and here instead of mouse X, it is going to be mouse Y. And last but not least, as I said, we need to do 2 more. I'm going to say player input component, and from here we're going to now bind, instead of axis, we are going to bind action. And the action is going to be jump. So when we press the jump button that we already set up, and we know that's the space button, so we are going to bind it inside of this. But instead of calling any functionality from here, I'm going to call the functionality from the a character class, and it's going to be colon jump, which is basically the function that we inherit from the character. And also here we need to add 1 extra parameter, which is IE pressed, which means when we press the jump button, we are going to jump. And now I'm going to copy this and paste it, because I also want to have functionality when I release. So it's here, it's going to be IE released. So when we release the jump button, we are going to stop jumping. That's all there is to it. And this A character is basically the character that we inherit from. So if I go here inside the player.h, we will notice that we inherit from A character class, which we set up initially when we, created this class. Now, what's going to happen here? Well, first things first, inside of our move forward, I am going to get the rotation. So I'm going to say here camera rotation, not camera boom, but camera rotation is going to be equal to get control rotation. And get control rotation is going to get me the pawns or the current actor, pawn, object, well, whatever you want to call it. It's going to get me his rotation. Next, I'm going to say here camera rotation dot pitch, because we don't want to rotate pitch, and over here we're going to say it's equal to 0.0, and then from there I'm simply going to say move direction is going to be equal to camera rotation, rotation, there you go, finally, dot vector. And this is going to give me the vector, which is basically convert a rotation into a unit vector facing its direction. So it's simply going to convert this camera rotation that we got from here into a vector facing the direction where we are currently rotated. And from there, I'm simply going to say get character movement. And from there, I'm going to say add input vector. So it's actually add input vector like that, passing the move direction. So it's direction multiplied with the value, which is the parameter that we have over here. And this value is either going to be 1 or -1, depending if we press the W key, it's going to be equal to 1. If we press the S key, it is going to be equal to -1. Also, if we press the A key, or actually, excuse me, the forward arrow, up arrow, that is going to be 1, down arrow, it's going to be -1. We are going to do the same thing for our move right. So I'm simply going to copy this and go over here. And for the move right, we're going to get the control rotation. We are going to set the pitch to 0, except over here, instead of getting the vector, what I'm going to do, I'm going to say camera rotation dot rotate vector, and we're going to rotate this vector by F vector, colon, right vector. Let me see if there is an explanation here. See, rotate a vector rotated by this rotator. Basically, it's going to rotate this vector, which we got from the control rotation, towards or to face the right direction or the right vector. And from there, we're simply going to add the input. So add input vector here, move direction, multiply with the value, which is either going to be -1 if we press the A or the left arrow key, or it's going to be 1 when we press the D or the right arrow key. Now over here for our mouse, there is not going to be too much work. We're simply going to say float input, and that's going to be equal to value multiplied with 100. And then we're going to multiply that with the get world from here and get delta seconds. There you go. And then simply we are going to say over here, add controller yaw input, and passing here the input. That's all there is to it. And we're going to do the exact same thing for the mouse Y. And here, instead of adding yaw input, we're going to add the pitch input for the Y. And that is pretty much it. That sums it up. Now, what we are essentially doing, and why am I doing this with 100? Well, basically, this is to smooth things out. And 100 is not like some default general value. Okay, use 100 in every single time, this is going to work perfectly, it's work like a charm. No, this is my testing. First I tried 10, then 20, then 30, then 100, then 1000, and got to the conclusion that the smooth movement with my mouse is going to be best with 100. Now I'm going to Control Shift B just to make sure that I didn't do any oopsies and everything is, build has succeeded. There you go. I am the best programmer in the world. I never make mistakes. So I'm going to go over here now inside of gameplay, and when we hit the play button, now we are going to be able to move. But as you can see, we do have some issues. Also, when I rotate the character left, everything works, but when I'm rotating him up and down, well, nothing works. When I rotate him up and down, it doesn't work. First things first, in order to rotate the character, we need to go here inside of our script, and right below here our follow camera, we are going to call here camera boom, And from there, I'm going to say B, use pawn control rotation to be equal to true. So this is going to give the control of the rotation to the camera, boom. I am also going to turn off the controller rotation pitch, yaw, and roll. So here B, use control rotation pitch is equal to false. I'm simply going to copy this, paste it. And here, instead of the pitch, we're going to say yaw. And here, instead of the pitch, we're going to say roll. Basically, this is not going to allow the controller to rotate our pawn on X, Y, and Z axis. So I can control Shift B to compile this, and we will need to wait a moment or two, basically a few seconds, because now I have the SSD. Just kidding. So now, if I hit the play button, we will be able to, as you can see, when I move the mouse up, actually it's moving the mouse down, and when I move the mouse, actually I'm moving it up and down. Yeah, basically now I'm moving it down and it's going up. When I move it up, it's going down. And I can also rotate him left and right, but we do still have one problem. If I move to the right side, you see he's not facing that side, and also going to the left is not facing. I will need to rotate and move like this, and now he is facing. But if I move it like this, he is not. First, I'm going to address the issue of the inverse rotation. Basically, that's over here inside of the input. Let me just find it, not in the editor, in the project input. So that is here on the mouse Y. So you can have here -1 or 1. So if we add here 1 now, and if I go back inside of the game and if I hit the play button, now when I move the mouse up, you see he goes up. I'm moving the mouse down, and there you go. You see he's going down. Moving it up, he goes up. Moving it down, it goes down. So this is the inverse that you usually see in the first-person shooter games. Inside of the options, you have that check mark or the check cube that you can check for, do you want the inverse rotation of the mouse? So basically this is how you set it up in Unreal Engine. Now when it comes to the rotation or rotating the facing direction where we are moving, we need to go back inside of our script, and right here below, so below all of these 4 lines of code that we added, we need to say here get character movement, and the character movement is the one responsible for moving the character. So I need to tell him that he should orient, so B, orient rotation to movement, that needs to be equal to true, because we want him to orient, basically means we want him to turn or rotate towards the moving direction. So I can control Shift B, and this is going to compile quickly. There you go, and I can go back now, and if I hit the play button, when I move to the left, actually to the right side, he is still not rotating. Now the reason for that is sometimes you see this right here, so I can go inside of the blueprint. Sometimes the code doesn't compile in the blueprints. I don't know why. I'm over here, I'm clicking compile. Sometimes you need to close the blueprint and open it again and all of that stuff. Sometimes I even need to delete the blueprints in order for this to work. I don't know why, but sometimes probably because I didn't turn off my computer, in a year. Anyways, what we can do to fix this is selecting over here. You see this top player character, selecting him. And now over here inside of the pawn, you see this one over here, you have this use control rotation yaw. We basically turned this off in the code. We need to uncheck this checkbox. Currently it's true. We need to uncheck this checkbox and compile and save that. But as I said, we turned this off. This is that, you see? This is in our code. We turned it off, but for some reason, it is not compiling in the blueprint. I don't know why. Don't ask me. If somebody knows, just tell us down below and we will be very grateful to you. But anyways, you need to turn that off, and now when you turn it off, I can go here and I can hit the play button. So now when I start moving, there you go. I'm moving to the right side, he rotates. If I move to the left, he rotates. If I move backwards, he goes over here. If I move forward, he rotates. I don't have to rotate him like this. I can rotate him, by the way, but you get the point. He is now, I can do this and the camera can be in one place, and I do not have to basically, do it by myself. Now, there are two things that I also want to address. The first one is the jumping. So the jumping is very, very low. And also over here inside of our blueprints, the capsule component, I want to resize it a little bit because it's a little bit too large, which is basically how we're going to detect collision with the player. So the half height of the capsule, I'm going to set that to 92, and the capsule radius, I'm going to set that to 24. So this is going to be the capsule for my character. Now, when it comes to the jumping, we need to go over here inside of the script, and we need to tell that to the character movement. So we need to say get character movement. Basically, I'm just going to copy this. And from the character movement, we are going to tell it, so greater than sign, jump z velocity is going to be equal to 700. So, of course, you can change this. You can change it to 800 if you don't like it. You can change it to, a higher, lower value. That will be totally up to you. But I am going to leave it as is, and I'm going to hit the play button. So now, whoa, this is too much. So definitely we will have to change it a little bit. Yeah, 700 is definitely too much. Well, actually, let me just compile. Did that compile? Let me just see that. Yep, definitely too much, I believe. Can we jump here? Yes. Anyways, that is up to you. You can play with that. That is totally up to you. I'm also even going to put this back over here, the -1 on the mouse Y, because it's a little bit easier for me to rotate like that on the mouse axis. There you go. Voila. And yeah, that would be it. This is for the character movement. So now that we have the character movement, we can of course start to program our enemy. Now again, as I said, this is up to you. You can change this, 60, 650, whatever. Compile and test it out. Anyways, if you have any questions when it comes to the movement that we did over here, the rotation that we did for the mouse Y, for the mouse X, also the things that we did over here, make sure that you ask in the comment down below. And yeah, if you don't want to wait every single day for me to publish these videos, you can access them right now, all the videos. I don't know currently at this recording because I'm on the third video, but I believe this will be a 20-30 video series, so you can access all those videos. They're available right now in my Game Development Academy for a small monthly fee. Access this and all other courses that I have in the academy, so you don't have to wait every single day for me to publish these. Anyways, I will see you guys in the next video. Alrighty then, my game dev gangsteronios. Now that we have our player, we can start creating the enemy. And over here in our C++ classes, I am going to right click and create a new C++ class. It's going to inherit again from the character. And this is going to be the enemy character. So I'm going to say not ebony. No, it's not good ebonying. So enemy character, there you go. And for those football fans or soccer fans, you know what the joke just was. Anyways, so this is going to be our script, and in this video we are going to prepare the script with a few things, not everything, because the enemy is going to be a little bit complex. Since it has AI, we need to create another script that's going to control the enemy and all of that stuff. So we're going to prepare it, and in the next video we're going to animate it and all of that stuff. So here it is. We have our enemy character, and the first thing I'm going to go here below are everything that's declared by default, and I am going to create here a few private, or just one private variable for the moment, and it's going to be uProperty, and over here it's going to be edit anywhere like that, and it's going to be class uSphere component, which is going to be used for collision. This is going to be called detect player collision sphere. And basically what I'm going to do with this sphere is this is going to be the huge sphere. So this is our enemy like that. This is the enemy, and that huge sphere is going to, or this sphere is going to be around him like this. And when the player touches that sphere, we're going to know, and then we're going to chase and hunt the player and kill him like an animal that he is. Now what I'm also going to do here is create a public, because we need a function that is going to return a uSphere component, which is also a pointer. So we need the star, and I'm going to call it get detect player collision sphere. Now this is it just for the moment, because we are going to have more things that we will need to add, but at the moment, as I said, this is it for now. And again, you see here I have forward declared the uSphere component. I also need to right click over here and declare or create the signature for get detect player collision sphere. We will see for what this is. Basically, we are going to add to this sphere component functionality to detect on begin play, actually on begin overlay, which is going to happen in the code. So we will see that. Now over here at the top, we are going to include everything. So I'm simply going to have all the components that I need. I'm going to include them right now. And you can, of course, you can just pause the video right now at the moment and copy all of these so that I don't go back and forth and every single time declare, oh, I need this, let's go declare it, include it, and all of that stuff. So I'm going to do it right now. And there you go. Now over here inside of our enemy character is where I'm going to create the detect sphere or detect player collision sphere. And that's going to be equal to create default sub object. And this one is going to be the U sphere component like that. And passing here the text, and the name of this one is simply going to be collision. So collision sphere. There you go. Like that. And we are going to say detect player collision sphere, and we're going to set up attachment on the root component because we want it to be attached on the root component. And over here we're not going to return a null pointer. Instead we're going to return the detect sphere or player collision sphere. So Control Shift and B for this to compile so that we can make sure that I did not do any oopsies. There you go. Everything is totally fine. So we can go inside of the editor. Now what I'm going to do is over here I'm going to right click and create a new folder for meshes. This I'm going to call it. And now we are going to import our character. Now this is, or these are the assets. So we have the mutant, parasite, and skeleton. You can download the assets. I will probably forget to put them below this video, so you can download them from the first initial video where we created a level, which is what I usually do. I put the downloadable files, the complete project, and the assets on that video. But you know, in case it's below this video, just scroll down. If you see the download button, it's here. If not, go on the first video and download it. Anyways, these characters are basically from Mixamo, and if you want to create them on your own, you can do that. I have a tutorial. Just search for Awesome Tudes Unreal Mixamo tutorial, something like that. You will find a tutorial where I download the character and I animate him and I, you know, do all of that stuff. But I'm not going to show you how that is going to be done from, you know, scratch. Go on Mixamo and click on the character. No, there is no need to do that because I already have a tutorial for that. So first things first, what I'm going to do is create here a folder because we are going to have the Parasite. So Parasite. We are also going to have right click and create a new folder, mutant. And last but not least, what was this one? Skeleton, I believe. Yes, there you go. So right click over here, new folder, and there you go, skeleton. So let's drag and drop one by one. So starting with the mutant, the first, what we are going to do is we are going to import the mutant himself. So simply drag him like this. And now over here, make sure that, well, basically we're going to use everything as default. So convert scene, everything, import animations. We're not going to check that. Skeletal mesh, import mesh. There you go. That's all there is to it. We're going to click here, import all, and it is going to import the mutant. No smoothing grouping. Don't worry about that. We don't care about that. But the point is that it has imported the mutant. If I click on him, for the mutant, we don't have a problem. Okay, everything is okay for his materials and everything. So now that we have imported the mutant, we can select the animation. So attack, idle, and running animation, and we can drag and drop all of these like that. So now we can import them one by one, or actually select them all, and they will be imported. And of course, you know, it will depend. You will have to wait a moment or two, but here they are. So this is for the mutant. Let's go over here for the parasite, but I also need to go here inside of my folder and parasite. And first I'm going to drag this parasite, which is the, you know, bad boy, and click here, import everything. And one of the people commented like, you don't teach right, you say bad boy. Yes, I do, because these are all bad boys. What can I do? Anyways, we will have a problem with the parasite. This is not the first time for me using this model because I like it. You see, it's, you know, for whatever reason, it is transparent. If you want it like this, be my guest, but I don't want him. So I'm going to click here on the parasite zombie material, double click on that. And from here, what I'm going to do is Here you go. This is the Parasite zombie material. I'm going to click on it and let me just dock it here. So I'm going to click on this, and now that you clicked on it, over here, you can change this blend mode, which is currently set to translucent. You are going to set it on masked. And then you're going to simply apply and save that. When you do that, our character or the zombie character is not going to be transparent anymore. As you can see, he is fully visible and all of that stuff. So you can see him and he will not be able to kill us with invisibility. So now that we have imported him, I can select all of his animations and I can drag them over here, and there you go. I can click import all, and it is simply going to import all of his animations. And last but not least, we also have the skeleton, which means that we need to go back over here. And from here, skeleton, let's drag and drop the skeleton. This is the first time I'm importing the skeleton, so I'm not sure. Maybe he will have problems with the materials. Maybe he will not have problems with the materials. I don't know. I'm not a psychic, okay? Do not judge me or whatever. But if I go here, apparently he does not have problems. Or does he? Well, yes, he does. There you go. I believe it's the same way to fix this. So let's go over here. Here is the material. Click on it and change it from translucent to masked and hit apply, and that would be it. So now if I go here to the skeleton, let's go Skelly, Skelly, Skelly. There you go. He is a brand new skeleton. Look at him. So moving back over here, selecting all of these again, his animations, we are going to go here and simply voila. There you go. I am going to click here, import all, and voila. So now we have imported all the animations, all the enemies, and all of that stuff. So of course, now we need to first create the blueprint for our enemies. Then we need to animate the enemies so that we can, you know, animate them in the game, and from there on we're going to add more and more features to all of our enemies. But this would be it for this video. This is just the preparation. As I said, starting from the next video, we are going to create a blueprint, which is going to happen over here inside the blueprints folder. So we're simply going to click here, blueprint class, and I am going to inherit from the enemy character, and this one is going to be BP Parasite enemy. It can be a parasite because, you know, this is a parasite. So if I go here, there you go. Now this, if you see, this is just before we wrap this video up. As you can see over here, we have the detect player collision. This is that sphere, but of course I'm going to make it a lot larger. So the sphere radius is going to be something like 1,500, and look at that. So this is that sphere radius, and when the player gets inside of the sphere, we will be able to detect that, and the enemy is going to start running towards the player. Now, of course, here for the mesh, we are going to click and select the parasite mesh. There you go. And what I'm also going to do for the parasite mesh is move him down by -90 and also rotate him by -90. And there you go. This is going to be our parasite. For the capsule of the parasite, click on here. And we are going to set the half height to 90 and over here radius to 24, and this is enough, I believe. There you go. We can compile and save that. So this is when it comes to our parasite. Now, of course, starting from the next video, we're going to animate the parasite, and I'm also going to give you assignments for you to animate the other characters and create blueprints from them, and that would be pretty much it. If something was not clear when it comes to this video, so we just created here a sphere. As you can see here, this is the name of the sphere, detect player collision, which is what we made in the code. And again, when the player touches anywhere inside of the sphere, anywhere, that means that we are going to detect that in the code, and we're going to start moving towards the player. If you don't want to wait and you want to watch all of these videos at once, you want to learn faster, you simply want to do it on your own pace, you don't want to wait for me to publish every single video every single day, you can access all the videos in my Game Development Academy. Link will be down below, and along these videos you will access all other videos that I have for my tutorials and over 80 courses. So that will be it, and I will see you guys in the next video. Now that we have our parasite in place, we are going to start creating his animation. Now, before we do that, I'm going to challenge you to try to do that on your own, because I already have previous Unreal Engine tutorials where I also create animation. I also use the parasite as well. So try to do that on your own. If you watch those tutorials, pause the video, try to do it right now. If not, that's still fine, but if you try, it's better even if you fail. So it's better to try and fail than not to try and not fail. There you go, that's wisdom. So what we're going to do over here in the content is I'm going to right click and create a new folder, and I'm going to call this one animations, and inside of this one we are going to right click and we're going to have the Parasite, so Parasite underscore animations. So inside of over here, I am going to right click, and first things first, under animation, I am going to go and create a blend space 1D. So for the blend space 1D, I'm going to select the Parasite mesh skeleton. So make sure that you select that one, and this one is going to be Parasite move underscore idle. There you go. So again, when you create this in the animation blend space, you need to select the mesh for the character that we are creating. So later on, when I challenge you to create for the mutant, you're going to select the mutant. Here is the skeleton, and so on and so forth. So this time was the Parasite mesh. So make sure that you do that. And when you do it, this is what you will see when you open this inside of your editor. Now, of course, the Parasite is still in the T pose because we did not attach any animations over here. But here what we are going to do is for the horizontal axis, I'm going to change the name to speed. There we go. And I'm going to set the maximum value to be 375. Which means that when I drag now the idle Parasite animation here, and I drag, so this is the idle animation that's being played, and I drag the running Parasite animation here, when I move the speed variable to here, you see when I say to here, I mean this is the idle right here, and this is the running right here. And this is the slider that allows us to preview that. And the slider is basically representing this speed variable. When the value of that speed variable gets to 375, we are running, which is going to happen like that. And there you go. So I'm going to save that, and now I'm going to go back, and over here inside of this animation we are going to create the blueprint. So I'm going to right click, and we are going to go under animation and animation blueprint, and again over here make sure that you select the Parasite. So don't select any other skeleton. So this is the one that we want. We want the Parasite mesh skeleton. If you try the mutant or if you try this one, it's not going to work. So we need the Parasite. So select the Parasite, click OK, and this one is going to be BP underscore Parasite. So it's Parasite underscore animation. Now going back over here, opening it, so we have the output pose, and we need to, create all of the poses and everything over here. First things first, for the variables, I'm going to click, and we're going to create the speed variable, which is going to be a type of float, and there you go. Over here, I'm going to right click, and I'm going to create a state. And that state is basically going to be, well, state machine, that is. So over here, state machine. This state is going to be the one holding the animations. So basically clicking on here to rename the state machine, we can say something like Parasite movement. This is how I'm going to name the state machine. And I'm going to double click it, and the entry here, I need to right click and add a state. And this one is going to be idle / move. So this entry is going to go there in the idle move, and I'm going to double click, and now we have the output pose where we are going to use the Parasite idle move, which is the blend space that we have created a moment ago. And over here I'm going to use the speed to plug it in, which is going to control that speed. And we saw when the speed gets from 0 to 375, then we are going to preview or play the running animation. We can compile and save this, and you will see at the top left corner that our Parasite is still in his default T pose. Now the reason for that is because, of course, we still didn't create any logic for him. We of course can plug this in over here, and I can hit the apply button, and now everything works. Now we will not want to plug this in like this. Instead, we will have to create something that is called a default group. So over here I'm going to filter for slot. And there you go. So we will have to plug in a slot, or this goes in a slot and this goes over here. Now the reason for that is because I am going to show you later on, of course, that when we create the attack animation, it's simply going to be a montage. So it's not going to work if we don't use the default slot. I'm going to leave it like this for now. I'm going to leave the slot over here. When we create the attack animation and we have the montage, you will see it's not going to work. And then I'm going to go back over here and show you that we actually need to connect the default slot and all of that, yada, 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 yada. Okay, so what we need to do for us to be able to detect this animation, or in terms of this animation will work on its own, that is, the parameter speed will be, you know, it will move based on the movement of the character and all of that stuff. So what I'm going to do is over here, I'm going to right click and we want the initialize. So we want the event blueprint initialize animation. And what I want from here is I want to cast to BP enemy character, or BP parasite enemy, that is. So this is going to be our parasite enemy. And who am I casting to? I'm going to cast this try and get pawn owner. I simply clicked on this node, Control C to copy it, Control V to paste it. I'm going to plug this in over here. So we are going to cast the pawn owner, and this is basically the owner who owns this blueprint animation. Now if that works, from here I'm going to create a node and promote it into a variable, and this one is going to be called enemy character reference. So there you go. And this, essentially what this is going to do, this is going to get the pawn owner, as I said, who owns this blueprint, so the animation blueprint, and then I am going to cast him into the parasite enemy. If that works, we are going to store it as a variable. So now we have a reference to the parasite enemy. Why do we need that reference at all? Well, we need the reference because now I can take the speed and I can set the speed over here like that. So from here I can set the speed and I can now get the reference of the enemy character. There you go. And I can get his velocity. So I can say get velocity from the character, there you go, and I can get the length, so get length, or simply I need to type length, which is, if I can spell length, that is, there you go, vector length, and this is going to be plugged in here, which means now this right here is going to get the character. This is going to get the velocity of that character. We know that the velocity will increase if the character is moving, which is going to happen because the character is an AI actor, which we are going to start creating from the next video. We're going to create that AI who is going to move the character, and when the character moves, then the velocity is also going to move, which means this vector length of the velocity is going to have a value that's going to be greater than 0, and when that value gets to the point where it is greater than 375, this speed variable is going to have that value. And this is important because the speed value is plugged into here inside of our parasite blend space, and we know that in the blend space when the value is 375, which means this right here, you see, it is going to make the parasite move. Now, of course, we unfortunately still cannot see this because I'm going to compile and save this, by the way. But as I said, we cannot see this because we still did not create any functionality for the AI, that is for the parasite AI, which we will start doing from the next video. But over here inside the parasite enemy blueprint, click on the mesh character, and for the animation blueprint, I'm going to select the BP parasite animation, and voila, there you go. So compile and save, and now we see that he is being animated. Even if I drag him, so if I go here from the content and blueprint, and if I drag him somewhere around here, let me see where he is. There you go. I'm going to position him on the ground. Voila. So he is going to be animated wherever he is. Even if I hit the play button right now, if I get close to him, you see, he's being animated in his idle animation. Of course, we cannot, here we can see it, how his arms are moving and all of that stuff. So he is being animated, but he lacks the ability to move and to do basically anything. So we are going to start doing that from the next video. If something was not clear when it comes to this video, when it comes to the animations and all of that stuff, make sure that you compile and save everything. Make sure that you ask in the comment down below. Also, your assignment is to create the animations for the other enemies. So for the skeleton and for the mutant, and over here for the level, I'm going to right click and create a subfolder. Well, yeah, it's going to be a subfolder of the level, and I'm going to call it enemies. There you go. And I'm going to place here the parasite. So I'm going to say here parasite enemy 1. And this is going to be our parasite 1 enemy. Of course, we are going to have the skeleton. We are also going to have the mutant. Make sure that you create that is your assignment. And yeah, if you don't want to wait for me to publish all these videos one by one, you can access them in the Game Development Academy along with more than 80 other courses. And I just blocked there, and I will see you guys in the next video. Now, in order for us to move the enemy, we are going to create the AI controller, and he is going to be the one responsible for controlling our enemy. Of course, we are going to do some things from the enemy itself, meaning from the enemy blueprint and from the enemy script or class, but the controlling of the enemy is going to happen inside of a separate script. So over here, I'm going to right click, and this is in the C++ classes. I'm going to create a new C++ class, and from here, show all classes, and we're going to filter for AI controller. And this is the one that we want to inherit. So click on the AI controller. I'm going to click here next, and it's not going to be my AI controller. It's going to be the enemy AI controller. So enemy AI controller, and click on to create the class. And I hope that you did the assignment I gave you in the previous video to create all the animations and everything for our other enemies, because we will also going to create those enemies with the AI controller and, you know, do our thing. So basically, now let's go inside of our editor. I'm going to click here to reload all, and here it is. So here is my .h file, and this is my .cpp file. Now, before we proceed to do anything when it comes to our AI controller, the first thing that we need to do is we need to find the .build file for our project, which is this one right here. So run to survive build, and this is it. So here it is. It has .build at the end, and the reason why we need that is because over here we have these public dependency module names, and we have this add range. So over here I'm going to click enter or hit enter so that, you know, it gives me the range over here. We need to say here comma after the head mounted display, and then over here in quotes, so as a string, we need to type navigation system. There you go. So make sure that you Control-Shift-B to compile this, because we are going to use the navigation system, and in order for that system to work, we also need to put it over here in the public dependency module names, which of course happens inside of the .build file of the project. So again, here is the .build file. If you don't do this, I need to emphasize this, because if you don't do it, it's not going to work, and then you're going to be, teacher, you said it's going to work, but it's not working. What is this? So yeah, you need to follow the instructions. Simple as that. So now going back inside of our enemy AI controller, I am first going to create all the variables that we need. So first we're going to start with the protected ones, and we are going to override begin play, not being, but begin play, like that. And I'm going to say here override. Also below, we are going to override the tick. So tick, which takes a float delta seconds, like that. Override again, because, you know, we are going to override it. We're not going to create our own tick and begin play. Next, we are going to have some private variables, so private from here. And don't worry about this. You see, we are going to implement all of that. Do not worry. Well, basically, while I'm here, I can right-click quick actions in refactoring, create the default, or simply for whatever reason it is not. Let me quickly go here. I need to do something like this. Not something, but this actually. Void a enemy AI controller, colon, begin play. For whatever reason, it's not giving me the completion. I don't know why. Do not ask me. And over here, we need to say super and begin play. Here it is, and there you go. I really don't know why it's not giving me the, you know, to basically do it on default like this one tick. I can go here and create definition. There you go. It works. But do not ask me, okay? Because I don't know. Private, and we are going to have a pawn, which is basically going to be our player pawn. So player pawn, and we're going to get a reference to the player, because we need to know if the player is in our range, if we are close to the player, and we cannot know that if we don't get a reference to the player. Next, over here, I'm going to create or forward declare a class a enemy character, and it's a pointer, so we need to add a star here, and this is the controlled enemy, basically the enemy that's being controlled by this AI controller. Over here we're going to have another forward declaration for you, navigation system v1, so version 1 nav area. There you go, like that. Next, we are going to have some variables that are going to help us to navigate, such as f vector, random location, which is going to be equal to f vector. This is going to be the random location that we are going to use to navigate in the level. Next, we are going to create a boolean b move to player to know if we should move to the player or not. Next, we're going to have b search for player. There you go, search for player. And bool b can attack player. There you go. So these are self-explanatory. This variable is going to determine if we can move or if we should or should not move to the player. This one is for searching the player, and this one is if we can attack the player or not. Next, we are going to have a float player stopping distance, which is going to be used by the navigation system to determine how close the enemy can get to the player before it stops. Over here, we're going to say float, and this one's going to be player attack distance, not a tatzel, it's attack distance, which is going to be equal to 200. And basically we are going to calculate the distance between the player and the enemy, and if that distance is equal to or less than this value, then we will be able to attack the player. Next, over here we're going to say void generate a random search location, which is going to do just what the name says, generate a random search location. Over here I'm going to say void search for player. There you go. Over here, void move to player. I don't think there is a need for me to explain what these functions are doing. They're self-explanatory. Search for player will search for the player, move to player will move to player. Void, here we're going to start chasing player, which is a function that is going to, make sure that we start chasing the player. Over here, this function is going to return a boolean, and we're going to test is enemy close to player. So for this is what we are going to use it. And last but not least, we're going to have void attack player. And I say last but not least, but actually this is only for our functions, because right here below we are going to have f timer handle. This one is going to be search timer handle, and I can simply copy this like that and paste it over here, because this one is going to be our attack timer handle. So let's go attack timer handle. We are still not done, unfortunately, because sometimes it can get tedious, as you can see. We are going to have void on move completed, which takes an FAI request ID. An ID is capitalized, and it's going to be called request ID. This is the name of the parameter. Over here, we're going to have a constant fpath following result, which is simply going to be result. There you go. And we're going to override this. This on move completed is basically going to tell us when we use the AI, for example, to, I don't know, search for the player, and we reach a certain destination. Let's see, this is the random location where we're going to go, and an enemy goes from here, reaches that location. Well, this is the function that's going to be called to tell us or inform us, hey, we reached that location. There you go. Next, we are going to have functions for begin and end detection. So over here, instead of me typing u function, there you go, then void on detect player and all of that stuff, I am simply going to paste it over here. So this is the on begin, and we're going to have one for on end overlap. And you can see how I named them. On detect player, begin overlap, on detect player, and overlap. These are basically going to be our two functions that we are going to attach to the sphere that needs to detect if the player has collided with us or not. So when it detects, this is going to be called. When the player exits outside of that sphere, this is going to be called. Now, what we need to do is simply right click and create all of these functions, definitions, that is inside of the .cpp file. So before we start to do anything, we need to do all of that. So let's go over here, create, and all of that. So from here, quick actions, refactoring, let's do that. Do not worry, of course we are going to start coding, not everything but some of these, because I don't want to make this video a 3-hour long one video, even though I did that before. Maybe I will do it again, I don't know. Maybe I will, maybe I will not. Who knows? Who knows? So now inside of our .cpp file, first things first, I'm going to include everything that we need. So just pause the video right now and include everything. I don't want to go back and forth, declaring and all of that stuff. So we need the Kismet gameplay statics, navigation system, enemy character, sphere component, box component, player character, and character movement. So just pause the video and copy all of these. Or you can download the project and simply copy from the project. Now, inside of our begin play is where we are going to do a lot of the initialization, such as our player pawn. We're going to get a reference to him, and we need to use the U gameplay statics, and from there we are going to say : get player pawn. Now we need to provide the world where we are going to get it, so it's simply get world. This is where we're going to get the player, and we're going to say 0th index because we don't have multiple players in our game. We only have one, and he is at the 0th index. So this is going to get us a reference to the player pawn. Next, our navigation area. So nav area is going to be equal to F navigation system, like that, : and here we're going to say get current, and we're going to say U navigation system v1, and over here we're going to pass this. Now, what is this teacher? What is this navigation system? Well, the navigation system is basically the nav mesh bound. So let me just Control-Shift-B to compile, make sure that we don't have any problems so far. And I'm going to go and create this navigation system so that we don't forget to do that later on when we test it. There you go, everything works. So basically this navigation system, let me just go back over here. We are going to find it. Let me just move this a little bit down. Over here inside of where it says place actors in the search class, I'm going to say nav mesh bounds volume. Here it is. I'm going to simply position it here, and I'm going to position it under or below the level. So it's part of the level. And this is going to be our navigation. Now what we are going to do with the navigation is I'm going to position it 0 for the X, 0 for the Y. And on the Z axis is going to be 290. And of course, we are also going to resize it. So scrolling down over here where it says the box, the X position or the X size is going to be 6,300. The Y is going to be 6,300, and the Z is going to be only 1,000. So if I save this right now, and if I hit the P button on my keyboard, there you go. You see this green thing? This is all navigationable area where our enemy, which is this one, there you go, enemy, enemy, enemy. So this is where the enemy will be able to navigate. And this is exactly what we are getting. So this is getting current. So F navigation system, get current. This is that navigation system that we are getting in our code. So when the game starts, we are first going to search for the player. So we're going to say here B search for player is going to be equal to true, because we are not going to start to attack the player right away, and even so that is going to be detected with the sphere for detecting if the player is near the enemy. So we are going to start by searching for the player. We are also going to say we can attack the player, which is normal because when we get close to the player we will be able to attack right away, and after that we're going to restrict the enemy from not attacking the player gazillion times. Over here we're going to say B move to player, and now this is going to be false because we're not going to search for the player and go to the player right away. So that is not going to happen. And last but not least, we need to say here generate random. So generate random search location and search for player. So this is what's going to happen right away when we run our game. Of course, this is not the only thing. We will do more things, of course, don't worry about that. But this is what's going to happen when we first start to search, or when we first run the game. Now, inside of generate random search location, which is this right here, we need to generate a random location within this navigationable area. So it's within this area. We don't want to generate some random location over here, make the enemy go over here, because it's not possible. Instead, he needs to generate a random, as you can see, navigationable area inside of these green, or inside of this green field. So how we're going to do that? Well, that is the reason why we got a reference over here for our nav area. So this is our navigation system area, which means now over here to generate a random location, we're simply going to say random location is going to be equal to nav area. And from there, we're going to say get random reachable point in radius. So get a random reachable point in radius, and over here we're going to pass this as a parameter. This is the world context. Basically, it is going to refer to the world where we are, where the navigationable area is. And over here we're going to say get pawn, and over here we're going to say get actor location, like that. And over here I'm going to say 10,000 points. Basically what this is going to do is the following. It is going to get a random reachable point in the radius in this world from this location, and this is the radius. So let's say that the current, and you see this get pawn is referring to the enemy. So the enemy is the one holding this script, this class, so it is referring to him. And over here, as you can see, get actor location, which means if the enemy is over here, so this is the enemy's location, he is right here. What we are going to do is we are going to cast a sphere or a radius of 10,000 points around this location and find a random navigationable point there. When we do that, over here inside of our search for player, we are simply going to say move to location and pass the random location to move towards it. So we can Control Shift B and compile this. And when we run our game, we will be able to see that, because if I go back now inside of our game, I'm going to hit P to remove that. If I hit the play button, nothing is happening. But teacher, you said, well, I did, and I tricked you there. Just kidding. Anyways, we need to do two things. First things first, we need to go into the blueprints, and from here I need to right click, blueprint class, and from here we need to search for enemy AI controller. We need to create a blueprint from the enemy AI controller. So over here we're going to say BP enemy AI controller. There you go. This is the controller for the enemy. Now we are still not done. It's not enough to only create the blueprint, but over here inside of the Parasite enemy, we need to click on the enemy over here, as you can see. So clicking on here, and then here for the pawn, you will notice that we have the AI controller class. So from there, I'm going to click and we are going to select the BP enemy AI controller and make sure that you compile and save that. And now the enemy will be controlled by this script that we have just created. Also, make sure that you do that for all other enemies that you have created. So you need to make sure that you do that as well. And if I go back over here and save it, so now if I hit the play button, you will notice that the enemy, look at that, enemy is, well, navigating to the point. Of course, the enemy is also behaving a little bit crazy, but you know, if I hit here and eject myself, look at that. You see, enemy is navigating to the point, but after he navigates to the point, he is not doing anything else after that. So basically he navigates to one point and that's all there is to it. He just stops there. So how or what we need to do to fix that? Well, for that, if you remember, that is the reason. So if I go back here and stop it, so let's go inside of our class. That is the reason why we have on move completed. I'm going to click here, press enter, there you go. So this right here, the first thing that we need to do is we need to call the super. So I'm going to simply say here super, and where is my... Okay, it was lost for somewhere. So super, and we're going to call the super on move completed and pass all of these parameters. So I'm going to take this on move completed, pass the request, so request ID, also pass the result. There you go. So now that we have called the super, what we need to do, you see this on move completed is basically going to be called when the move from the enemy, so when the move is completed simply. And after that happens, I'm going to say here or test if the B search for player. So if search for player is still active, then I'm going to generate another random point. So generate random search location and search for What is this? Why is it giving me? So search for player. There you go. Give me the correct one. So Control Shift B, and this will be, we will compile this. There you go, successfully. So essentially, when we first run the game in the begin play, we're going to generate one random search location, and then from there, we are going to start and search for our player. But after that, so after we reach that location, nothing happens, as we saw in the preview. So then we need to go here in onMove completed, which is going to be called when the move is completed. And when I say move, I mean this, move to location. When this is over, and when the enemy moves to the random location, then we are going to test in the onMove completed. So the move has completed, enemy has reached its destination. If we are searching for the player, so if this is true, okay, generate another random location and start searching for the player again. So let's test that out. So if I go back over here, hit the play button,